everyone for coming. For those of you who haven't attended a Science Cafe before, this initiative was started back in 2014 to sort of give graduate students an opportunity to present general science related to their research to a broader community. Today we have Brianna and Erin who are going to talk today about pollinators. Brianna is a third-year graduate student in the entomology department, looking at sort of understanding the epidemiology and transmission of pathogens in bee communities. And Erin is a second-year graduate student also in the entomology department, where she focuses on bees and agricultural systems and how we can work to support those populations through habitat alteration.
Okay, well thank you everybody for coming here. Today Brianna and I will be talking about pollinators, specifically the tricks and treats of pollinator health, from poor nutrition to pathogens. And yes, we're both in the Department of Entomology, so Brianna will lead us in.
So there's a multitude of different types of pollinators. These can include insects such as your bees, your butterflies, your moths, and your beetles. These also can include animals, including bats, birds, monkeys, possums, rodents, lizards, and snakes. Now, of these animals, the monkeys and such, you probably will not be finding pollinating here. That would be in the tropics. However, you probably have all seen birds, such as hummingbirds, in your gardens pollinating flowers. However, for the remainder of this talk, the two of us, because we both work on bees, are going to be focusing on the bumblebees, honeybees, and solitary bees within the system. So, like I said, this includes bumblebees, honeybees, and solitary bees. Your bumblebees and your honeybees are both social insects, which means that they live in a colony and they help each other out. They work as one organism pretty much. And these also are both generalists, which means they forage on a multitude, diverse set of different flowering plants. However, your solitary bees can range in their social aspects. So they can be totally solitary, not living in a colony, or they actually can be somewhat social in that they have their own colonies, but they're kind of interconnected. And they also typically are more specialized on certain flowers. So for example, one solitary bee is the squash bee. So there's a squash bee that mostly pollinates squash plants.
So why are pollinators important? Aside from the fact that they're beautiful, they're fun to observe, you can walk around outside and have an interesting day collecting different bees. They're also incredibly important to support our food supply. 75% of crops are actually dependent on animals for their successful reproduction. And also when it comes to wild species and wild plants, 80% of these are dependent on pollinators for successful reproduction. So not only is it important to have a diverse supply of food, but also for economic value, especially here in the US, where it's a very agriculturally based economy.
However, pollinators have been in decline for the past 15 years. So this has been estimated due to both honeybee colony losses as well as range reductions in pollinators. And what I mean by range reductions is, for example, we used to have a bumblebee here, Bombus pennsylvanicus, and that used to be the most common bumblebee. However, in my past 2 years of collections, I have not caught one of these. So it's no longer typically being found in Pennsylvania, and so its actual range, so where you can find it in the US, is reduced.
So when we talk about this decline, it would be easy to try to simplify it, and so that's what has been done in terms of the 4 Ps of pollinator decline. So when we talk about the 4 Ps, there are 4 different factors. 1, parasites, 2, pathogens, 3, poor nutrition, and 4, pesticides. And each of these separately can affect pollinators' health, fitness, but when interacting, they can be incredibly destructive. So that's why if you look at all of these 4 factors together and the interactions that occur between them, that's where we're really seeing the decline of these populations.
So we're going to briefly talk about 2 of these and then focus on the latter 2. So quickly, pesticides. When we talk about bees, the main one that we talk about is neonicotinoids. And this was a pesticide that was initially started to be used because it was determined to be more safe for animals. However, what we're finding with pollinators is that they are having a huge impact on these pollinators because they're systemic pesticides. And what I mean by that is that the pesticide, when it's applied, can be transferred throughout the entire plant, ending up also in both their pollen and their nectar. In addition, these pesticides have been also seen increased use in the past 15 years, so we've also seen declines in bees, and also when they're applied incorrectly, such as was done in Oregon, when they were sprayed during bee foraging times, there can be massive die-offs.
So parasites, essentially just to broadly define a parasite, is one organism utilizing another organism, its host, usually for nutrients, but usually this relationship has a detrimental effect on its host's health or fitness. And so with pollinators, what you're going to hear a lot about is the varroa mite in honeybees. And what this is a mite, it essentially attaches to the body of honeybee workers and it will suck out the hemolymph. So it'd be like having a basketball attached to your side that was constantly draining you of nutrients. Not exactly an ideal situation. Because of this, it's incredibly destructive to the colony, and that's why we're seeing some of these really large colony numbers that are dropping across the U.S.
And so for the remainder of this talk, because Erin and I's research is on nutrition and pathogens, we're going to be focusing on the poor nutrition and the pathogens that are affecting these bees.
So pollinator nutrition, if we were going to generalize it, just like humans, bees need carbs, proteins, and fats to survive. And the way that they get these are primarily through pollen and nectar. So if you look at pollen, the main nutrients that it supplies are proteins, fats, and amino acids. And this is really critical for larval development in both social bees, where it's going to be important for the colony to develop, and in solitary bees, where it's going to be important just for the individuals to develop. And then when we look at nectar, this is where they're getting carbohydrates and also some amino acids. And when they consume this nectar, it allows them to move about through the landscape, to forage on different flowers, and essentially provides them with a more instant energy, kind of like if you were drinking juice. And so where they're getting all of these is obviously flowers, and I'm sure you've observed in your garden, bees are out on flowers, and that's how they are getting these nutrients. So normally what would be ideal is if bees had these landscapes where there's a variety of floral resources or flowers that they can pick and choose from. So not only are you having flowers all across the season, so May, June, July, all the way to September, whenever you're seeing bees that are flowers out there, you're also seeing flowers that have different amounts of pollen and nectar that might better meet some bees' nutritional needs. And they can also have certain types of nectar from one flower and certain types of pollen from another flower. And in doing so, it really supports a variety of bees and really supports large numbers of bees. And this is what keeps these populations going over time. But because of human activity, primarily in the form of habitat alteration, we're seeing landscapes where we would normally have these meadows, where you have a variety of resources and flowers, being changed into something that's more of a monoculture or an agricultural type system, where they have a single resource that's available at one point in the season. So if you think about the apple orchards that are available or that are present in the early springtime, where you have these beautiful flowerings, they're available in that early spring period, but after that there's no resources really available for the bees. Another type of habitat alteration we're seeing, which is even more destructive for pollinators, is when we're going from these meadows that have a variety of resources to something like a golf course landscape, where it's essentially being maintained so as to allow no bees, no flowers present. And because of this, bees are being forced to forage farther distances, or they're being unable to find resources at all. So this is something that we're seeing that's also incredibly destructive. So if you were to think about it from our own diet, normally we're able to pick and choose from a variety of different foods that have different qualities of nutrition. Maybe sometimes you'll eat a lot of chocolate and other times you'll eat a lot of fruit. And instead of having all of these resources to choose from, it's being reduced down to a single resource that maybe is delicious, but it might not actually meet the needs of your body. And so if you're going to talk about a specific instance, this is just something from my own research. So bumblebees, which is what Brianna showed earlier, those large furry bees, are out in the landscape just in this region if you think about some of the farms. And pumpkin, you may have seen a lot of pumpkins recently. That's actually a mass flowering crop like I discussed. So there's a lot of pumpkin flowers that bees are able to go forage on and collect pollen and nectar from. So if you look down here, there's pumpkin, sunflower, and sunhum. And those are 3 different types of pollen and nectar that they can get from the landscape. And then we looked at how large their ovaries are. And so what this would carry over to would perhaps be how successful they are at reproducing, how many offspring they're able to reproduce. And what we found is this mass flowering resource, the pumpkin, actually produces the smallest ovaries, whereas the sunhump and sunflower, which are actually more beneficial, but might not be found as often, are producing larger ovaries. So just like if you think about in the landscape what's out there and what effects you're seeing on the bees, this kind of can give you a visualization. So not only are bees being reduced to some resources that might be lower in quality and might be only available at a certain point in time, but they're also being forced to forage farther. So for example, normally this bee would be able to fly to this flower, collect pollen and nectar, and then go back to its colony, but because of habitat alteration, now it's flying twice as far, and it has to forage obviously twice as far, and that's an increased energy expenditure. So in general, the health of the bee is being affected by this habitat alteration. So poor nutrition, if we're talking about it in like a very general perspective, it can reduce the fitness and the health, so the ability to reproduce. It can decrease the population number, so how many bees are able to persist in a landscape. And it can also make them more susceptible to pathogens and parasites. So they're weaker as a whole and not actually able to fight off some of these other factors that might influence them.
So what we're going to do for trivia is, there's lots of paper laying around, so just write down your answers on the back of the paper, or keep them in your head. There's pens and pencils over here if you need one. So I'm just going to read through all the questions we have, and then at the end of the presentation we'll go back and get the answers. Sound good? All right. So let me know if you need me to repeat a question. I'll just start going through. The first question is a true or false question. All bees can sting. True or false? All right. Question number 2 is also true or false. There's a lot of true or false in here. Only the male bees sting. True or false? Only the male bees sting. All right. Question number 3. Honeybees are the only type of bees that produce honey. True or false? Honeybees are the only type of bees that produce honey. Wasn't that hard? Question number 4. True or false? Bees typically live in giant colonies and never as individuals. True or false? Bees typically live in giant colonies and never as individuals.
Are these questions from your campus?
No. That'd be funny though. I can ask you some that were in my campus.
Question number 5. What are the 4 P's of pollinator decline? All right, and last one. Name one parasite or pathogen of bees. Or disease. Parasite, pathogen of disease.
That'll be coming.
Does anybody need me to repeat a question? All right. And after the talk, I'll give you the answers, so stay tuned.
So, like was announced, I'm Brianna. And so for my research, I look at bee pathogens. So bees are affected by a multitude of different types of pathogens, similar to how we're affected by a multitude of different types of pathogens. So both bees and humans are affected by viruses, bacteria, and fungi. And so just as a brief overview, pathogens is anything that is like a virus, a bacteria, or microorganism that causes disease. So how are bees picking up these diseases though? So floral resources, as Erin talked about, are a great source for nutrition, and bees need floral resources to feed on. Floral resources are also a place where bees can pick up different pathogens. So when bees are visiting these flowers, they actually are depositing either spores or feces on these flowers, and then the next bee that comes to visit can pick up this pathogen. And this is passed on through the pollen. So this is figured out when someone actually tested bee pollen that they're carrying and found diseases in that, but not in the bee themselves. And so this is similar to in humans. So when you have the flu and you're sick, what sorts of things can you pass to other people? Germs, maybe. And so how can those germs be passed along? Potentially through a doorknob, right? So if you are sick and you sneeze on your hand and then you touch a doorknob, the next person who comes along might pick up that disease as well. So that's similar to what's happening to these bees on these flowers. And in addition, these pathogens are actually being transmitted between different types of bees. So the pathogens can be transmitted from bumblebees to honeybees and vice versa. as well as research is being conducted right now to see if these bee pathogens can actually be transmitted to the solitary bees as well. And this currently is being called pathogen spillover. So when pathogen spillover occurs, it's when there's a group that's a hub for a certain pathogen, and then that's transmitted to the groups that are around that organism. And so what's interesting in this sense is that these pathogens among these different bee groups, so as you can see here, we have the honeybees, the bumblebees, there's solitary bees, also a social wasp, so similar to bees, closely related but not the same, and then flies, which are distantly related. They're actually looking at them and seeing how these different pathogen levels vary in both the incidence as well as the virulence of these pathogens. So as you can see in this figure here, it's a little complicated, but I'm going to break it down. So the important thing to get from this is that, one, the pathogens, so these different gray bars, which are different viruses that are affecting bees, they differ in which bees have which pathogen. So for instance, these honeybees look like in this study, they only were found to have these two viruses. Other studies have shown that these other viruses can also be affecting honeybees. But at this site, at this time, the incidence is varying to the bumblebees, which actually have 4 of these different viruses. And in addition, if you look at the social wasps, they also have 4, but they have increased prevalence. So potentially, you could say, maybe they're more susceptible. So this is similar to us in humans. Some pathogens have higher incidences in different groups, especially in different places. So for instance, you're more likely to find malaria in Africa than you are here. And furthermore, the susceptibility of these diseases differs. So a lot of the studies that have been done on these pathogens have been done in honeybees. So in honeybees, for most of these pathogens, we know the symptoms, and we know how likely they are to kill them. However, in these other groups, a lot of that information is not known. We don't know how virulent many of these pathogens are to these other bee groups. And so this would be similar to in humans, where some of us are more susceptible to things such as strep throat or things like that than other individuals. And so for my research, I'm trying to look at an overview of the epidemiology of pathogens. So this would include understanding the locations or localities that these pathogens would be found in. So I have sites that are natural, urban, and wild, and agricultural. That's natural. And what I've found so far is that the communities, so the diversity of pathogens, so you can see there's more bars, more different colors in that natural site than the other 2 sites. So each bar is representing a different disease. So the natural site is having a higher diversity of different pathogens. In addition, what I found was interesting is each of these sites are only a 15-minute drive from each other. So I would have expected the pathogen communities to be practically the same among them, and yet these pathogen communities are different, which suggests that this might be occurring at a very, very local scale. Furthermore, in order to understand these diseases and manage these diseases, it will be important that we understand their seasonality. So as humans, we know that the flu, there'll be a spike of the flu in the winter, which is why you get your flu shot in the fall. For bee diseases, we don't know what the trend is for each of them other than in honeybees. So I have done research looking into the bumblebees at some of these diseases, and I'm continuing to do these studies. But from my preliminary data, it appears that the viruses are lowest at the beginning of the season, and then in all, except for this strange case with one of the viruses that you see in the middle, are increasing throughout the season and becoming more detrimental. So what this suggests is that, similar to poor nutrition, pathogens can lead to reduced fitness and health, and also decreased population numbers. Furthermore, depending on the pathogen, how virulent it is, and its symptoms, it can result in decreased ability to forage, reduced successful mating, inefficient workers, and prevention of colony growth and founding. And so what Erin and I are trying to really push into you guys is that there is no one silver bullet that's causing this bee decline. It's an interaction between all of these different factors that are occurring. So interactions between pesticides, pathogens, parasites, and poor nutrition. And so, for example, in this study, they looked at the interactions between nutrition, immunity, and the varroa mite. So if you have good nutrition, you'll have good immunity. If you have good immunity, your colony can grow. However, if you add the varroa mite to this equation, then you actually, the varroa mite will decrease your immunity in the bee. It'll also then result in increased viral titers and virus, and your colony is more likely to fail. And this is somewhat similar to the interactions we have as humans. If you aren't eating healthy, you're more likely to get sick. If you're not sleeping enough, you're more likely to get sick. So with that, we're going to look at your guys' answers to your trivia questions and answer any questions that you guys have.
I was curious, so with all the different species of bees that can have any variety of these virus infections, mostly I think I saw, is it always, are the viruses always disease-inducing, or do you have times where you have seemingly healthy bee colonies that have the virus present?
Right, so there are, that's what I was talking about with, especially, so like in honeybees, and if you want to know more about this, I'm guessing there are honeybee people in this room that might know. There's a lot of the honeybee viruses have symptoms. So like deformed wing virus is one of them, and that's called that because those wings shrivel up. And they've found in bumblebees that you can have deformed wings as well. However, some of the viruses are asymptomatic, and so you don't know that your colony has the virus until it's too late usually. Does that answer your question? Yeah.
So, just when you look at like wasps versus bees, are bees usually the fuzzy ones? Or
Yeah, so
is that how you tell?
So to tell a wasp from a bee, so close, technical answer is that bees have branched hairs and wasps have straight hairs. But if you're looking close in the field and you don't want to get that close to them or under a microscope, usually the bees are going to be a lot fuzzier than the wasps.
If it's chasing you, it's probably the walls.
For the bee's immune system, how is it similar to or different from humans? Does it have
I actually don't know the answer to that. I should know the answer to that. Does any other of the bee people know about the bee immune system?
Yeah, they don't build up their immunity. They don't have, what is it called? You build up your immunity. Something that recognizes a pathogen. Antibodies. They don't build up antibodies because they don't live long enough to have a learned immune system. So they have an innate immune system with just a series of deoxidizers and kind of general suppressants, but they don't learn.
Do you have any sense of what mechanisms are driving the virus dynamics? So why it so consistently seems to increase over the season?
So I have some hypotheses, I guess. So one of my hypotheses that I'm testing, so that was just bumblebees so far. And so one of my hypotheses is looking at life history differences. So my hypothesis is that because bumblebees, so a bumblebee colony only survives for the season. So a season is from like March to September, October. And so in bumblebees, the only organism that survives is the future queen. And they overwinter by themselves. And so I'm assuming that if they're stressed out from a pathogen and they go into this stressful situation, the sick ones might die. And so bumblebees might have a way to actually purge pathogens, which would be why they're low at the beginning of the season. I haven't tested honeybees yet, but my hypothesis is because they actually overwinter as a group, they keep warm in the colony, that might be a reservoir for pathogens, introducing them back into the system. We'll see if the hypothesis is correct or not once I test them, but that was what I was thinking. Anything else? Oh, the other thing is some studies have found, that there's they're called gynes, or the future queens, might have some immune function that allows them to be less susceptible to pathogens.
What about the pathogens?
Yeah. So, do you want to talk about the nutrition aspects, or do you want climate change, or?
Does it show to why people?
Yeah, so there's some bees, so in general, climate change is going to affect a lot of the bee organisms, because there's some that, bumblebees are temperate. Do you want to answer this?
Yeah, I was just
Yeah.
bumblebees would be the most sensitive simply because of their, they're found in more temperate regions. So if you start finding them if their like normal location starts becoming warmer and warmer, they might not necessarily be able to thermoregulate. And furthermore, whether or not the species that they normally are foraging on are still going to be present, they might not actually find the pollen and nectar that they're needing. And then also, if you want, like when it comes to overwintering or the diapause period of queens, whether or not like a flux of warmer temperatures might cause them to emerge. I think that we saw that earlier this year when there was that warmer flux, and then it appears some of the bees emerged, and then immediately after it started getting really chilly again, and all the flowers actually perished from the frost, and that meant that any queens that were already out were not able to find resources. So that could have actually had a really detrimental population effect, at least in this area.
And there are some bees out towards the west in the Rockies that are they're high altitude bumblebees, and so those are going to be more likely to be, they suggest, infected because they'll get pushed pretty much out of their temperature range, possibly.
All right. So your answers to the trivia questions, I'm just gonna ask the question again, and I want you guys to tell me what you think. So, all bees can sting, true or false?
False.
Correct. Only the male bees sting, true or false? False. That's false, right?
Yeah.
All the questioning in the audience. Honeybees are the only type of bees that produce honey. True or false?
Oh, true.
False.
False. Technically it's
By the
false.
definition of honey.
Yeah.
Yeah, but those are nectar pockets. We don't have a better word for it.
I mean, you should taste it.
Have you tasted
tasted
bumblebee honey before?
We don't know.
Have you tasted it, Patrick?
Sorry?
Yeah.
Have you tasted it?
Yeah.
I haven't.
It's the same.
Is it just
very
it's
similar.
It's the same texture, the same color, the same taste.
All right, I'll
It's just not as much of it.
So we're good with false.
And I think maybe
All right. Bees typically live in giant colonies and never as individuals. True or false? False. Yeah. Haha. Make you doubt yourself. All right. What are the 4 P's of pollinator decline? So those are pollinator decline. Yeah. 4 P's of pollinator decline.
Pathogens.
Yeah.
Pesticides. Parasites.
Poor nutrition.
Poor nutrition. All right. Good job.
And
And
I think one was skipped. Yeah.
oh, I thought I heard
I
4.
just counted
Sorry.
3 P's.
one.
Yeah.
Wait, we had pesticides,
Pesticides. Okay.
pathogens,
There we
parasites,
go.
and poor nutrition. All right.
Perfect.
Great. And last one. Name one bee pathogen, disease, parasite. Let me hear it. Yeah.
Bee loss.
You guys hear any wrong ones? Though?
I didn't hear any of them. Parasite.
Yeah.
So we have so the varroa thing.
Yes, that's a correct answer.
That's the correct answer.
You guys are good at this.
I'm just going to read off what we have on here for answers, and then, you guys feel free to add or detract from my statement as necessary. Mites, hive beetles, foul brood, chalk brood, stone brood, lots of paralytic viruses, etc., etc.
See, lots of pathogens.
Are there any other ones that you want to highlight apart from those?
Deformed wing virus, probably.
Yes,
Okay.
viruses. There's a fungus, Scaspera.
I think that covers
There's also
them.
some cool, like, nematodes.
There's a parasitic fly.
Yeah.
On bees.
Is that the one that pops their head?
Does it?
Something pops
Oh
their
no,
head.
that's the fort. That's another fly.
There's lots of cool.
Yes.
The poor bees. All right, so that's all the trivia questions. Does anybody have any questions about any of the questions and answers? Anybody get them all right? All right.
Yeah. Well, if you have more questions, feel free to contact either of us.
Right.
Thank you everyone for coming. Thank you Brianna and Eric. Thank you to Flo for hosting us, and thank you to everyone on the committee that helped organize this. So, thank you all for coming.